So today we're going to be identifying functions linearity, which is it linear or not? Like we just said, linear means straight. So is it a straight line or not? And we're going to talk about continuity. Okay, so whether it's continuous, discrete, or neither. And we'll see what that looks like in a little bit. So a linear function, this is what we learned last year, right? Y is equal to mx plus b. Does that sound familiar to you? Mm-hmm. Yeah? Okay. So a linear function is a function whose graph is continuous, straight line. Have a good day, Raven. It can be represented by an equation written in the standard form. Did you guys learn standard form? It's an equation. Alex, you remember what it is? That would be it's like slope-intercept, but with a proportional relationship. Here, standard form is like this. Capital A, lowercase x, plus capital B, lowercase y, equals capital C. Have we learned that or no? No. Perfect. We're learning it today. That's the Pythagorean theorem, but yes.
That's the thing that looks similar to this. I know why. What does E equals F equals? You're making this stuff up.
I don't have homework to do, so it's your homework time. You guys are eating right now. I can make these notes 45, 55 minutes if we want. Okay? In this standard form equation, every x value is paired with exactly one y value, right? Every input needs one unique output. Otherwise, we don't have a function at all. So I provided a nice little checklist as to how we know our function is linear or not. So if we're looking at a graph, we would see a straight line. That's obvious, right? If we're looking at an equation, there needs to be a y in the equation. The exponents of x and y have to be 1. Okay, so if you see an x squared, right away you know that's no good. X and y can't be multiplied together. And x and y can't be in the denominator, in the exponent position, or in a square root. Okay, so what we can't see, is something like 2 over x, 3 to the power of y, or the square root of 2x, something like that. Anytime we see one of those weird things, we know right away it is not going to be linear. Okay, same thing with our third little note here. We cannot have x squared, y to the third, and so on. And of course we can't have 2xy. If all of these conditions are met, yes, all of these conditions, right? Not some of them, all of them, then we know that the function we have is linear. Right? This is something we all should know, hopefully. Linear functions have a constant change in x that corresponds to a constant change in y. What does constant mean?
Forever.
Forever? I heard someone say repeating. Keeps going repeatedly forever. Sure, that's a great summary. Right? So let's look at a couple of tables. If I want to figure out whether this is linear or not, it's very simple. All I need to do is draw a little arrow from one y value to the next and ask myself, how do I get from 210 to 420? What am I adding to 210 to get 420? 210. What am I adding to 420 to get to 630? 210. What am I adding to 630 to give me 840?
210.
210. So 210, that's my change in y. This little triangle is the Greek letter delta that represents change, right? So my change in y from output to output is 210. What would my change in input be? Plus 1, plus 1, plus 1. We have to do it for all of them, because that's how we make sure that it's a constant change. If I look over at table B, what's my change in x on table B? Plus 1, plus 1, and plus 1. So far, so good. Let's do my change in y. How do I get from 1 to 4?
3.
Plus 3. How do I get from 4 to 9?
Plus 5.
Plus 5. How do I get from 9 to 16?
Plus 7.
Plus 7.
It's definitely not linear.
Okay. Do we have a constant change in y here?
No.
Nope.
Evens.
They have to be the same number, like we had over here with 210. So because my change in y is not constant, that means this is not going to be a straight line. Okay? Which of the tables above is linear? Table A or table B? Table A. How can we tell table A is linear?
Because the x and y values are constant.
The x and y values are constant? A little more specific.
It's a straight line when you graph it.
Well, you're on the right track. It's not the x and y values that are constant. It's the change in x and the change in the y values. Right? Take a look. Constant change in x, constant change in y. That's what we're looking for. But yeah, you basically have the same thing. We have a constant. That's not constant. That's constant. Constant change in x and a constant change in y. If we were to plot that, we would have a nice straight line.
What does that say?
Where?
Y.
This? We have a constant.
No, after the constant.
Change in x and a constant change in y.
That's the delta.
It's a triangle.
It's a Greek.
Yeah, triangle x, triangle y. Okay? Which of these tables is nonlinear?
Table B.
Table B.
Yikes.
How can we tell table B is nonlinear?
The constant change in y is change in y.
Exactly. Thank you, both of you. Yep. There is no constant change in y. That seems pretty straightforward enough to figure out, right? As long as you know how to add, we should be good to go on that. Now, just for fun, anyone have an idea of what my equation for table A would look like? If I was going to write an equation for that relationship, what would it look like?
1x plus 1.
Actually, you know what? Take 30, 60 seconds with your group. Try and figure out if you can write an equation for table A and write an equation for table B. See if you can figure it out.
1 plus, no, 1
No,
plus
you
what?
guys are so. This is the equation.
You're so smart, Alex.
Yeah, I am.
Hey, never mind, calm down.
Alright.
What are you writing? What's your writing?
So this is A in parentheses 1. Hey! He's cheating! He's cheating! He's cheating!
Yeah. You know how he does that?
And then B.
Oh my god, you're so smart, Alex. No, it's gonna be 1.
A. Yeah, 1.
But it's not constant. What do you write?
What do I do for that?
It's a bipolar. I just
I'm just gonna put B. I mean,
But isn't it plus?
You're writing an equation on this one and that one? you're gonna write what you think they are on here and then write your group number.
I think I'm supposed to do that. I don't know.
So real quick, just to make this interesting, as a group, on that little blue paper, you should be looking at the blank side. Okay, write your group number on the top. If you don't know what your group number is, look up. Okay.
2.
And then you're going to write table A with an equation, table B with an equation. We'll see who's right. So take 60 seconds with your whole group. So if you're in the front, turn your faces around so you can talk to the people in the back. You can work with your group. You guys can do it. It's easier with the less people. More, I don't know. I made that up.
I think it's because 3, like, it's 3, right? And it's plus 2, so 5. I think it adds 2.
Yeah.
It adds 2, right? Plus 2. I don't know.
Bro, be quiet. The other one.
Where the smart people
How would I write this in a
write our names on it. I want credit for that. Davis, I love your hair.
Okay, you guys done?
Yeah.
Give me a thumbs up if you're done.
Write our names over here.
Okay.
So when we see it,
30 more seconds.
It's plus 2, bro. I swear if it's plus 2, I'm gonna have so much patience. If plus 2 ends up being
If it's plus 2, then it's just gonna be 5. But there's more than 5.
You guys got it?
Alex, if he says I'm plus 2 with the correct answer, I'm actually gonna do something.
If we do that, we get 5. But we include Peace God, Alex. How would we do that?
Right down.
Well, I'm like so confused.
I'm not telling him, bro. I think he hates me. His friend, I think his friend hates me. Me and his friend have beef. We did unexplainable, bro. Hate his friend. I told his friend that
Me too.
no, candy is my
Perfect.
Okay, I think I might teach Cody.
Let's see. Everybody better have gotten the first one.
Yeah, it's
That's y
Yeah.
equals 110.
what?
Close.
Be the answer.
Not close.
How did y equal?
Correct.
Am I on
Correct.
something or? We're so cool, I got it.
We have the equation here, so we should use it.
Bro, wait, is it?
I didn't say anything.
He looks so disappointed.
I didn't say anything.
Do we win anything?
We'll see how many people get it right if you win
Can we
anyway.
get extra credit?
I
want more extra credit.
Where did he get the Oh my goodness, cost like a 90. How do you have the
Interesting.
He's so disappointed in us, I can tell.
Okay, 3 groups got it, which is great.
Mike, was Mike in one of them?
No, it was not. Okay, let's take a look.
But which group got it right?
I think almost everyone got the first one right. Right? This one's easy because this is linear. This is just y is equal to 210x. Right?
Alex, you're such a
Because 210 times 1 is 210. 210 times 2 is 420. Times 3 is 630. You guys with me? Kyle, why are you sitting like that? Your legs should be on the inside.
Do you guys hear that music?
Okay. Anyone remember what type of relationship this is called here? Not only is it linear, but it's what?
Proportional.
Proportional. That's right. That's not going to matter, but it's good to know. Now, in table B, there's 3 groups that got it right, which is great. Group number 4,
Oh my god, it's so wrong.
which would be over there. Yep. Ladies over there. Group number 7,
We're so wrong.
fellas right here. And group number 8. In the back.
This is why you said this was it.
Literally is on the paper.
Alex felt this ring. Is it not right?
Take a look. Here's the equation for that relationship.
What the sigma?
Y is equal to x squared.
Alex, we don't say it again.
So let's go one by one. What is 1 squared?
Oh.
What is 2 squared? Hold on. We're not listening. What is 1 squared? What is 2 squared? What is 3 squared? What is 4 squared? What would the next point on here be? 525. Great jobs. Groups 4,
We don't even get anything. What do we
7, and 8. You'll get candy.
I don't like your out, Alex.
There were some of you guys got really close. Some of you got some stuff that
Equation. Why did I use it?
is creative at least. Group 6, you were super close.
Mr. Church.
Super close.
Mr. Church. You put this here to trick me.
I didn't say it was in standard form, did I? No. Anyway. So yeah, this one is y equals x squared. Now, here's why I do this, okay? What stands out about this equation to you? How do you know it's nonlinear, Arish?
Because it's not constant.
Okay, pretend the table's not there. Just looking at the equation, how can we tell it's nonlinear? Tristan? It's got an exponent that's greater than what?
1.
1. Take a look. My third criteria here. My exponents of my variables must be 1. If they are 2, or 3, or 4, or 5, it is not going to be a straight line. Okay? If we wanted to plot this, right, let's just say, if I got 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 1, 1, 2, 4, 0, 0, 3, 5, 6, 7, 8. 3, 9 is like there. 4, 16 is like up there. So what this ends up being, as we'll see in a little bit, is a curved line. Yes?
If we kept going, would it curve back into a full circle?
Nope. Because what's 100 squared? 100,000, right?
What?
Is it 100,000? 10,000?
10,000's 100.
No.
Is it 10,000?
It's 100.
10,000. Wait, yeah, it's
Yeah, it is. It is.
Oh yeah, it is 10,000. My bad. So the point would be 100 and then 10,000 on the y. So it would be way out.
Yeah, I
Yeah.
just keep going up.
It wouldn't make a circle.
I wanted to make a circle.
All right. Anyway, let's take a look at the next one. Now this is where your little standard form is going to come into play.
Oh. Bro, I feel like so tired.
I know, but we still have to, you know, do what we got to do.
Let me know
I'm
what's
tired.
going on because I don't know.
How many papers are you gonna give us?
Alex Martin is so mad, you know?
I'm not that smart.
Bro, I thought you were smart. No, in 7th grade, you would always go back to the
Yeah, we got different lives. Why am I losing like that?
Alex, how is your weight like 105%? You said it was that high. But you said it was not higher.
How many papers are we gonna have?
I'm not doing this. What's your weight in this class?
What?
How is your 100%?
Don't worry about that. I don't like that question. That question is rude.
Oh, somebody asked me this question.
You have 100 equals.
He at least gives you the rest of the people this one.
Miss Moses is so bad. I don't know where you're wrong. That's crazy.
We make like robots and things and stuff. What the sigma?
What?
Okay. You guys all glued in?
Yeah.
I said, are you guys all glued in?
Yes.
Okay. Then let's get started. So how can we tell if an equation is linear or nonlinear? All right. Well, we can look back at our criteria. Number 1 doesn't matter because we're looking at an equation. Well, we need a y. We need my x and y to have an exponent of 1. They can't be multiplied together, and they can't be in a weird position, like underneath a fraction, up top as an exponent, or inside of a square root. Okay? But we're not always going to know right away. Sometimes we have a little bit of cleanup duty that we need to work out. And that's when we're going to put our equation into standard form. Okay? Everybody got a highlighter? Okay.
That's where we use that.
Alex, you should.
I still got it.
Oh, it's not even.
I just forgot. I literally said.
Okay? Go ahead and highlight A, B, and C. A, B, and C are going to be numbers. Okay? What do we call this A and this B? Anyone remember the term? It's kind of a weird term.
Variables.
Such as a C.
Coefficient.
Coefficient, right? Because they're where?
In front of the
In front of a variable. What do we call this C on the end? Constant. Good. Great job, Yusuf. That's right. So if we look at number 1, does that look like it's written in standard form? No. Luckily for us, we know how to solve equations. I'm going to split my equal sign. And what I want is this form right here. I want some number x plus some number y equals a constant. That's what I want. If I can put it in that form, we know that it's going to be linear. Okay? So what can I do here to kind of start that process? Alex, what can I do?
Subtract 4x from both sides.
Okay, I'm going to bring all my x's and all my y's over to the left. So I'm going to subtract 4x, subtract 4x. Now I've got negative 2x minus 3 equals 3y minus 2. what can I do now? Liana?
You're gonna add 3 to both sides.
Okay, we'll bring the constant to the right, add 3 to both sides. You guys remember this, right?
Yeah.
A little bit different because there's a y now, but it's all right. Okay, what can I do now?
Subtract both sides by 3y.
Perfect, exactly right. Subtract 3y from both sides. I'm going to bring it over here. I've got negative 2x minus 3y equals 1. Is that written in standard form?
Yes.
Yeah. Here's my A. There's my B. There's my C.
D.
No way you just have pop.
So here A is negative 2. B is negative 3. C is 1. If we can write it in standard form, then it is linear. If we wanted to, we could then rework this equation again, write it in y equals mx plus b form, and graph it nice and easy. Right, if we add 2x over to the right and then divide both sides by negative 3, we have a slope of negative 2/3. We've got a y-intercept of negative 1/3. We can plot that, and we'll see it's a straight line. How are we feeling on number 1? Okay? So I would start out with equations, right? Make sure we're really good at them. Number 2, what jumps out to you about number 2? Alex, what is peculiar about how number 2 looks?
The exponents on
The-
on the letter X.
Okay.
That's 3.
Can we have exponents on our x and still have a straight line?
No.
No. But again,
Be only 1.
we're not just going to judge this equation, okay, just by looking at it. We got to do a little bit of work first, okay? And you'll see why when we get to like number 3. I'm going to split my equal sign for number 2. Is there any like terms I can combine on the right-hand side?
Yes.
Yeah, what can I combine?
3x cubed. Minus x cubed.
Yeah, 3x cubed minus x cubed. What would that give me?
2x cubed.
2x cubed. Right? There's an invisible 1 in front of that x. Okay.
Do we subtract both sides by 3x?
Maybe.
So we could, there's a couple things we could do now, right? We could bring, oh yeah, let's just do that.
Can we just?
Yeah, we'll subtract 3x from both sides. That's what you said, Anthony, right?
Yeah.
Yeah, perfect. Good thinking. 3x's go away. I've got negative 3x plus y equals 2x cubed plus 6. How can I get that 6 all by itself?
Minus 6 from both sides.
Minus 6 from both sides? Minus 2x cubed from both sides. Okay, I'm going to rewrite this over here. Negative 2x cubed minus 3x plus y equals 6.
So that's the answer.
A, B, C, D.
Well, the answer is, the question is this linear or not? Chloe's shaking her head no. Give me a thumbs up if you agree that this is not linear.
Wait, but how would you tell if it's linear?
It has 4 answers.
It has 4 answers.
4 letters.
It has 4 letters.
Yes.
How would you tell if it's linear?
Well, let's take a look back.
Linear because
Take a look. Take a look. Here's how we know.
exponents x and y are 1. This is.
My exponents for my variables have to be 1. I can't have an x cubed, a y squared, none of that.
Yeah. So that's why it's not.
So because, here, let's write this in there.
Oh, because 2x is cubed, it's not linear.
That's right.
Yeah, it's not linear.
So we would see a curved line with an exponent, nonlinear. My exponent for x must be 1. Mr. Church, why do we have to do all that work? I saw the exponent at the very beginning. Can't I just say nonlinear and move on with my life? Well, let's look at number 3. What do you see in number 3 that jumps out?
No. It's
Parentheses, good. I see an exponent too, right? Look at that, 2.
That's
So
not
right
true.
away, what is my brain going to tell me this is? Linear or nonlinear? Nonlinear. Let's not judge a book yet. Let's work this out. Gurpreet said she noticed parentheses. What can I do with those parentheses? Distribute the 2.
The 2
I'm going to distribute it to the 2, and I'm going to distribute it to the x. So what do we have? We have y equals 4x squared minus, what's 2 squared? 4, and what's x squared? X squared plus 3x minus 5.
Yeah, we do. We can combine like terms, but
Okay,
Actually,
let's
yeah,
hold
we
on.
can
Let's
do
wait
that.
for everyone to get here. I feel like I'm going a little fast. Maybe not. Probably
I'm
not.
gonna say.
What can I do now on both sides? Alex, you already said it.
combine like terms.
What like terms can I combine?
4x squared minus 4x squared.
Well, what is that equal to?
0.
Perfect. Do I have any exponents now?
Nope.
No. So you're going to see equations try and trick you. Okay, put little exponents in there that actually end up canceling out. That's why we have to do this work, okay? Now, I still want to write it in standard form. I can do one thing here on both sides, which is what?
Subtract 3x from both sides.
Perfect. Thank you, fellas in the front. Minus 3x. Boom, boom, boom. We end up with negative 3x plus y equals negative 5. Is that written in standard form?
Yes.
Sure is. What's my a equal to?
Negative 3.
What's my b?
1.
And what's my c?
Negative 5.
Perfect. A is negative 3. B is 1. C is negative 5. This is linear. Very quickly, last but not least, number 4. I again see exponents, but I also see parentheses. So Alex, what do I want to do first?
You want to do the thing inside the parentheses first.
Okay, we're going to take care of these parentheses by doing what with that outside
We
2?
distribute the exponent to
Okay.
3 and x.
Now, be careful, right? This is not 3. This is square root of 3.
Square root of 3x.
Is x inside the square root?
Oh, no.
No.
Wait, this is
No, it's not. It's on the outside.
Yeah.
Right? If it was raining out, that x is getting wet because it's not underneath the little umbrella that my 3 is under.
Oh.
So x is on the outside. My coefficient is root 3, right? Which is like 1.5 something. Okay?
Yeah, it's 1.
So what's the square root of 3 squared? Sorry. Yeah, no, I said that right. What's the square root of 3 squared?
3.
Just 3, right? They cancel. The 2 and the radical cancel out. What is x squared, though? X squared plus y minus 3x squared equals 10. Anything I can do here to clean it up?
Can we?
You
Ava?
add,
Combine like terms. What like terms can I combine, Ava? Perfect. What do those combine to make? 0. They cancel out. X plus y equals 10. Is this linear or nonlinear?
linear.
Linear. Because we could write it in our standard form. There's no greater than 1 exponents on my variables. My variables aren't aren't an exponent themselves. They're not in a square root. What was the other one? Oh, they're not in the denominator.
Yeah.
And they're not being multiplied by themselves or by each other. What would my A and my B here equal?
1.
1. And what's my C?
10.
10. All right? Any questions we can answer about that?
No.
Perfect. One last thing to see before we get to our work, because this is not going to be in our notes, but it's pretty straightforward. If you're looking at your book, and we're on 3.3. What did we say that continuous meant again?
Goes on forever.
Yeah, it goes on forever.
Goes on forever, not quite.
In a line.
Yeah, we can connect all the points with one single line, right? So if I were to look at this function, right? This one right here. Give me a thumbs up if that's continuous. Give me a thumbs down if it's not continuous. This one right here that I'm pointing at. Is it continuous or non-continuous? How about this side of the room? Anybody? Continuous, non-continuous? Okay, good. It's continuous. We see one nice solid line through the whole thing. Pretty straightforward. What about this one? Continuous, non-continuous. What do you think? Yeah, this one's super ugly and super weird, right? There's a couple of lines, but are all of the points connected with one single line? No. So that is not continuous. Is this discrete?
Yes. No.
No, discrete's just a bunch of points.
Yeah.
So this is neither. This is somewhere in the middle.
So what would that be?
It'll be neither.
And a abomination.
Yeah.
We're leaving
No,
like
you're
20
a
minutes.
mistake. My fault, guys. My fault.
Hey man, that's not very nice.
Stop touching my stuff.
Even your stuff, it came with a box.
Stop touching my people.
What's that phone called?
We'll talk about it in a second.
Full library.
So this is neither. Okay, this is continuous. This is neither. What about this one here? What would this one be?
Discrete.
Discrete. There's no connecting lines, but there's a dot. What about this one here?
Neither. Neither. It's neither.
Neither. Why is it neither?
Because there's a line.
Little tiny line.
I didn't see that.
Little tiny line. Okay. What about this one?
Continuous.
Continuous, right? It's a line. That should be good.
Okay, let's.
All right.
What numbers do we have to do? What?
What did I say it was?
1 to
Like, what was it?
1 to 23 odd.
Perfect.
Oh, no. We're screwed.
Page, what was it?
164.
164. You have great memory.